Alrighty, everybody. Welcome to the Morrison Planetarium. Just a heads up, folks, we're going to get started in just another minute or so. We're going to see if any other folks are going to come on in and join us for the last planetarium show here at the museum. Oh, actually, we just got the okay to start right now. Perfect. We're just going to wait for this last trivia question to come on up and finish. And just a reminder, folks, these planetarium shows that we're in here right now, they normally last about 30 minutes. So just to let you know, the museum closes at 5 o'clock. So this show is going to take you to the very closing of the museum. So hopefully this is where you want to be for the last 30 minutes of the day. I think it's a good place to be. All right, y'all. So now we got the okay. So I want to put away our space trivia questions because now we're going to be heading into the unknown. Ooh. And once again, folks, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter. And just a heads up, I'm not a big spooky voice coming out of the walls. I'm actually a person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt you next. I just want to let you know that I'm here. I'm going to be your pilot in this planetarium show. Look forward into the dome before you. That's where the whole show's going to be. And just to let you know, folks, the show that we're going to be doing in here is one of my personal favorites to do. What we're doing right now is called Tour of the Universe. And essentially, what that means is that you're going to hear my voice for the next 30 minutes. And pretty much, we're going to start off pretty close to Earth and we're going to zoom all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space. We are very, very tiny. And before we get started, I got to go over some quick house rules just so that we're all on the same page. You can have a great experience inside the planetarium. First off, there's no food or drinks allowed inside. So if you manage to bring any snacks or beverages, make sure those are tucked away till the very end of the show. We want to make sure this theater stays nice and clean for all of our guests coming in. This also does include no feetsies on the seatsies because, again, we want to make sure the seats stay nice and clean for all of our guests. So thank you, folks. Highly appreciate it. Also, folks, if you happen to have any cell phones or smartwatches or tablets, anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes. These devices produce really bright white light that can be distracting not only to yourself, but for the folks sitting behind you. This planetarium is going to get quite dark. And also, folks, please wear your mask at all times while we're in the planetarium above your nose. There's quite a few of us in here, and we're going to be in here for 30 minutes. So, again, highly appreciate your help. Thank you so much, y'all. And also, folks, if you need to exit the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where the exits are going to be before, during, and after the show. So when in doubt, always make your way up the stairs, not down. And last but not least, folks, this show can be very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. Hee hee hee. But otherwise, that's all I have to say. Y'all ready for a cool planetarium show? Hey, alrighty, everybody, sit back, relax, and let's get started with our tour of the universe. Alrighty, everybody. As I mentioned, I said we're going to start off with this tour pretty close to planet Earth. And we're going to be starting off right here at the International Space Station, which is right before us, or what we also like to call the ISS for short. Now, the International Space Station is one of my favorite things that we humans have ever done together. Pretty much, this is a research facility that's orbiting around planet Earth. And this is a collaboration between many nations across planet Earth to pretty much figure out what happens to things in space. For example, how do plants grow out here when you try to grow a plant out here in space? Does it behave the same way as it does as plants on Earth? What happens when you try to drink water? Or what happens when you try to ignite a flame? Does it behave the same way? What happens to humans when they live in space for long periods of time? So these are some of the different questions that scientists want to figure out, especially things that they can't replicate here on planet Earth. And just to let you know, folks, the International Space Station began in 1998 thanks to Russia. Russia sent up the first module, which is right at the heart of the ISS. And since then, many nations have pretty much added different modules to it, so it's been getting bigger over the years. But what's really amazing about the International Space Station is that this thing is going incredibly fast around our planet Earth. It travels once around our Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day, going a whopping 17,000 miles per hour. Woo! And not only that, it's not too far away from planet Earth. It looks really far away since we're at this perspective. But the International Space Station is only about 225 miles above the surface of the Earth. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip with the family for the weekend. And just to let you know, folks, the International Space Station is the biggest thing we humans have ever put into orbit around our planet Earth. And it's about the size of a football field. But again, it keeps getting bigger every year because they keep adding new compartments to it. And it fits about 6 to 8 astronauts at a given time, living in these small modules that we see right at the heart of the International Space Station. So just right over here. And just to let you know, folks, the International Space Station is as far as we put humans into space nowadays, because traveling out into space gets quite expensive quite rapidly. First, you got to get your hands on a rocket ship or build yourself a rocket ship. And then not only that, you have to get your hands on a whole bunch of rocket fuel and more rocket fuel to get that rocket fuel off the planet and that spaceship. And not only that, you have to account for your crew, all your food, water, all the air you're going to be breathing while you're out here in space. So the bill starts to get quite costly quite rapidly. But let's leave the International Space Station behind because this is just our first stop in the tour. We're going to see it slowly disappear compared to planet Earth. And before we lose the International Space Station, I'm going to bring up a nice little orbit line so we can keep track of it as it slowly fades away. And just to let you know, folks, the software that we're using right now for this planetarium show is something that you can technically go home and download if you like, if you want to fly through space just like how I am right now. This space program that I'm using is called OpenSpace. So if you go to Google and type in OpenSpace project, you'll find the website and you can download it. Although, just a warning, this program is in its beta phase, so it means it's not completely done. There's a few bugs and glitches. So if we do encounter any bugs or glitches, I'll point them out to you. But not only that, this program also takes up a whole lot of processing power and storage space. So if you don't have a new computer or a gaming computer, I wouldn't recommend it. This is going to make your computer go really slow because it has a whole lot of information that it needs to pull from. But if you still want to fly through space and you don't want to download anything, there's also a really cool other option, which is called NASA's Eyes. So just like your eyeballs, NASA's Eyes, if you just type that into Google, you don't have to download anything and you're still able to fly through our solar system. But let's leave planet Earth because we're going to be making our way over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science experiments. They got to play golf here as well. And it looks like we are almost at a new moon, so I'm going to use our special planetarium power so we can see turn off the nighttime on the moon. And there we go. That looks familiar. And just to let you know, folks, the last time we sent humans to the moon, that again, 1972, a little more than 50 years ago. But don't worry, NASA has a new space mission in the works, which is called Artemis. And it's supposed to launch sometime next year. Cross my fingers, everything goes according to plan. But with Artemis, NASA is going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up a lunar base on the moon. Pretty much with Artemis, we want to send humans to Mars. But before we send humans all the way to Mars, which is deep in our solar system, we humans need to figure out how we're going to live out here on another celestial body out here in space. So again, instead of sending humans all the way over to the red planet, we could use something much, much closer to home, which is our moon. But what's also really neat is that not only are we going to have bases around the moon, we're also going to have like an international space station orbiting around the moon, which is going to be called Lunar Gateway. So if anything was to go wrong on the lunar base, these astronauts can launch off and head to that Lunar Gateway, that international space station, so they can be somewhere safe in case things go wrongly. But again, look out for any news for Artemis in the coming years. Cross my fingers. Hopefully everything goes according to plan. And not only that, folks, when we look up the moon here up on planet Earth, It looks incredibly close to us. It almost feels like sometimes you can reach up your arms and touch the moon. But the moon is incredibly far away from us here on planet Earth. It's about 240,000 miles away from the Earth. That's a quarter of a million miles. Some of you folks may own a car with that many miles on it, and if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop. Although I couldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers use a more convenient measurement known as light speed. Light travels at a mind-boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But for now, let's leave the moon behind. So everybody say bye bye, moon. We'll see you later. And now, folks, we're going to be taking a leap into a much greater realm of our solar system because now we're going to watch the moon and the Earth in their orbits as they slowly recede. In fact, let's add our orbits of our planets so we can see where they are out here in space. And on our journey, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models showing us the most accurate images and information available to us. For example, OpenSpace. And now our nearest star, the sun, comes into view. Now, the sun is incredibly far away from us, folks. It's about 93 million miles away. In terms of light speed, that's about 8.5 minutes at the speed of light. Whew, that's a good distance away. So again, we are the third rock from the sun. So that third orbit line right over here towards the top. Now, this is a really cool concept to grasp because let's say if the sun was to turn off all of a sudden, we humans here on Earth wouldn't know about it for 8.5 minutes because it takes that long for that sunlight to last bit of it to be emitted, and it would travel that 93 million miles, and then finally that last bit of sunrise or sunlight would reach us, and then it would, all of a sudden the daytime would be nighttime. This is a really cool concept to grasp because this works really well for really far away objects. For example, let's say we're looking at a star that's 60 light years away from us. Well, we're seeing that star as it looked like 60 years ago in the past because it takes that long for that light to reach us. So when we're looking at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now we're looking at a nice bird's eye perspective of our solar system. So let's name the objects really quickly. So of course, right in the middle, we have our star, the sun. The closest planet to the sun is going to be Mercury. Then we have Venus, Earth, and Mars. These are the rocky terrestrial planets. These are places we can actually land a spacecraft on if we like. And then beyond the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if we highlight all those asteroids in our asteroid belt. There we go. And then beyond the asteroid belt, folks, we have the really big planets, the gas giants, the Jovians. We have Jupiter and Saturn. And then beyond them, we have the icy giants. We have Uranus, the funny one, and Neptune. And of course, we can always add everybody's lovable and favorite dwarf planet, Pluto. So here's the orbit of Pluto. And just to let you know, folks, Pluto is no longer considered a planet as the year 2006. A lot of people tend to ask me, hey, Christian, why did Pluto get kicked out of the Planet Club? I love that planet. I learned about it in school. Viva la Pluto. Well, you see, folks, in 2006, we scientists got really well at studying about the outer parts of our solar system, specifically the orbit beyond Neptune, in a region called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that. Well, the Kuiper Belt's going to be all this stuff. So we found more than 400 objects out here in the Kuiper Belt region, and we couldn't call all this stuff planets. There was just way too many of them. So all the scientists across planet Earth came together, had a great big meeting. They had to figure out what exactly you need to be considered a planet. And one of the criteria to be a planet is that you need to be so big and so massive that you push all the other objects out of your orbital path. Unfortunately for Pluto, it doesn't pass that criteria because it's not that big and it kind of gets pushed around. And not only that, it orbits its moon. So again, not the biggest object in its orbital path. So this is why Pluto is now considered a dwarf planet and not a planet. But don't worry, Pluto's not the only dwarf planet out here. We've got quite a few of them. We've got Makemake, Haumea, just to name a few. And not only that, we also have Ceres, which is in the main asteroid belt closer to us. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding some of the spacecrafts that we sent out in the 1970s to explore our solar system, how we got to learn about it. And now here comes the trajectories of those spacecrafts. There they are. So the trajectories that we have here, we have Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons. Now, all of these objects are traveling fast, are the fastest traveling human-made objects. They're all traveling fast enough to escape the sun's gravity and leave our solar system behind. But what's really cool is that the latest of them, New Horizons, did a quick flyby of Pluto in 2005, which we can see that intersection just right over here. So that's New Horizons leaving our solar system. That faint blue line, of course, that is Pluto. And thanks to that mission, we were able to get some amazing high definition images of Pluto because in the past, our images of Pluto were pretty much pixelated little blue dots. But New Horizons just did a quick flyby, continued on its path. So we don't have a complete model of Pluto. We just have like 75% of it, but still really good stuff. But let's leave our solar system behind, folks, because we still have a ways to go to the very edge of our known universe. And now we're going to be leaving the planetary scale far behind because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And if my calculations are correct, right in the middle is our solar system. So the nearest star system to us is Alpha Centauri, which is over here, 4 years at the speed of light on the bottom left. Now, if you were to get in a rocket ship of today and you wanted to travel to the nearest star system, well, that's going to take you about 8,000 years. Whew, that is a very, very far distance and long road trip. But folks, we're going to stop and consider whether humanity has made its presence known beyond our solar system because now we're going to be heading inside something called the radiosphere. Now, the radiosphere represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space, and it extends about 90 light years, emitting in all directions out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, and radar signal, and then the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So, is anybody out there listening? And folks, I'm going to be adding up these markers onto our screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found more than 4,000 exoplanets in the nearby vicinity to us, and that number is going to be increasing in the near future because we have new space-based telescopes where their whole sole purpose is to find as many exoplanets as possible. So that 4,000 is going to be increasing as the days continue. But to figure out if any of these exoplanets have life as we know it, or conditions for life as we know it, well, our technology is not yet able to answer that question, but new generations of astronomical instruments are devoted for that search. The important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody out there that's able to listen in and answer back, the communication delays between hellos could be decades in time. To give you an example, let's say we live in a star system on the far left of our radiosphere. We find an alien civilization towards the middle, let's say 60 light years away from us. We shoot them a text message, hi. They listen in, answer back. They send a message back saying, hi. That's another 60 years. That is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to put away our exoplanet markers, but I'm going to leave our radiosphere structure up on the screen. As huge as our electromagnetic footprint is, it is nothing compared to the Milky Way Galaxy. So let's zoom all the way out and take a look at our Milky Way Galaxy from above. Alrighty, everybody. So now we're looking down on our galaxy, the Milky Way, and our Milky Way galaxy is incredibly large. If you wanted to cross our galaxy from one side to the other, it's going to take you about 120,000 years at the speed of light. Whew, that is enormous. But not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave the Milky Way galaxy, I do want to stress the shape of it. When we look at the Milky Way galaxy from a sideways perspective, you notice that we live in a flat spiral disk. Now, this is going to come important later on the show. So, when astronomers and scientists want to learn about our universe, it's so much more easier for them to point their telescopes and equipment galactically north and galactically south instead of looking through the Milky Way plane, which has stars, planets, black holes, gas, nebula, things that obscure their view of the universe. So, again, just keep that in mind. We look galactically north and south instead of looking through the plane of the Milky Way. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, we're now going to see a view where every single point of light that you're now seeing no longer represents a star. It now represents the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture expands, folks, you're going to notice that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large clusters or groups, and they like to leave voids where there's very few galaxies. So we can see a nice galaxy cluster on the bottom left of our screen, and we can see some nice voids on the very far right of our screen. So just keep that in mind. Galaxies like to hang out in groups or avoid each other, just like people. Hee hee hee. Now, folks, we've zoomed out so far. Now, this picture that we're looking at represents the 30,000 closest galaxies to us in space over 300 million light years. We got to give thanks to an amazing astronomer by the names of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation with the work of dozens of other astronomers working over decades of time. So, again, big shout out to Brent Tolley for creating this intergalactic map that we're able to fly through in our planetarium today. But folks, now we have automated systems that are mapping the most even distant galaxies. So now we're about to see the large scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star, it's an individual galaxy containing hundreds of billions, even trillions of stars. Woo! And let's fly through all these galaxy clusters, and now we can see the large scale structure of our universe. Just a heads up, folks, the universe is not shaped like a bow tie or a butterfly. The reason why we have this dark gap right in the middle is again because if we were to line up our Milky Way galaxy, the Milky Way plane would line up directly in the middle, vertically like so. So again, astronomers point their telescopes and equipment galactically north or galactically south. But scientists still want to make sure that there was galaxies through the plane of our Milky Way. So we have this nice purple galaxy survey right over here in the middle. You're going to notice that these galaxies are much more closer to where we are and not as far out. Hopefully in the future, our technology will improve and we'll be able to look through our plane of our Milky Way and we'll be able to map all these galaxies through the plane of our Milky Way. So these dark gaps will be eventually filled in. It's only a matter of time. But it looks like we're running low on time, folks, so let's continue pressing on to the very edge of the known universe. And now, folks, we're going to be heading out so far back that now we're going to be looking at the brilliant cores, the central nuclei of very young, very distant galaxies known as the quasars. Now, the quasars are going to be on the very far edges of our large-scale structure. So these are the quasars, all in orange. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We are nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now let's head we're going to press back even much further to a time before planets, stars, and even galaxies began to form. Folks, we are about to arrive to the very edge of the known universe. And here we are. So, what we're looking at, folks, is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This all comes from data compiled by Planck and other radio telescopes. And this picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, we're looking at a temperature density image where the light echoes of the Big Bang are color coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to the large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how this happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we've gone back as far as the law of physics can physically allow us, so we only have one direction left to go back home. So, let's find a nice cluster of galaxies to fly through as we make our re entry back to planet Earth. We have some nice clusters here. There we go. That's a good spot. And before we make our return trip back to planet Earth, folks, I've got to ask y'all to prepare yourself because this could possibly be the worst free falling dream ever. Hee hee hee. But let's make our way back to planet Earth. Now, folks, we're crossing the expanse of 13 billion light years, and we present you with this view of our universe in the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I'll remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back into our Milky Way disk, and we're heading straight for that radiosphere. And of course, now we're making our way back to our solar system, our planetary disk. We're seeing the brightness of our sun, and now we're passing the orbit of Pluto and all those spacecrafts that we sent out in the 1970s to explore our solar system. We're flying past that asteroid belt right to the third rock from the sun. And folks, as we approach Earth, our final destination, I want to thank y'all for stopping by and watching Tour of the Universe with us today. I hope you did enjoy it. But remember, as we're returning back to planet Earth, Earth is the only place we humans have ever lived. So just remember to take care of it. But otherwise, that's all we have for you today, folks. And again, thank you for stopping by. I hope you had a good time.